Hi, my name's Stuart Williams and I'm a Magenic, and today we're going to talk a little bit about containerization, about choices and strategies for the cloud. This is probably the single most prevalent question I get asked when I'm presenting on various cloud things. How does the cloud and containers work? What are the choices? What's the state of the art? And so I thought we'd cover that today. At the 10,000 foot level, I don't want to talk about specific container products or strategies, but I do want to touch on kind of the big three strategies. And I want to make it clear that to some degree, virtualization, as we're used to it, that is running Hyper-V or vSphere or something, is a form of containerization. At the bottom of the well, there's a physical file that represents the machine definition and a physical file that represents the hard disks. In traditional container systems, there is a container, which for all intents and purposes is an archive like a tar or a zip. At runtime, those files are used as the basis for a computing platform, and their contents provide the guidance for how those things will run. And all three of these strategies are available in the public or private cloud. Obviously, you can do a hybrid between those two things. Private clouds have the advantage of full IT control and isolation. Public clouds often offer lots of value-added services like deployment and management. And I want to point out that properly implemented, public clouds are every bit as safe as private ones. In fact, if recent history teaches us anything, in many ways, the big public cloud providers, because they have more in the way of reputation to lose than individual IT organizations, are often more hyper careful around security things. But at the bottom of the well, organizations have to own their own security and compliance. They have to do their due diligence. They have to do their testing, and they have to do their management and monitoring to make sure that not only is the system in compliance when it's shipped, but that it stays in compliance as new versions happen or as it's being operated. I should also point out that in the container universe, just like in the virtualization universe where common virtual machine formats are now the norm, there is an open container organization format upon which the two most prevalent container systems, Docker and PCF droplets, are based. And you can go to the hyperlink we gave you and read all about that if you want. Which is not to say that everything that runs in one will run in the other. It just means that they derive from a central set of ideas and standards, and then each layers or embellishes or extends those in order to make those run. Okay, terminology. So in the bottom three layers of all three are the same, right? You need a data center, you need networking and storage, you need servers to host things. Typically in the virtualization scenario, you have virtualization hosts that run, VMware, vSphere, Microsoft Hyper-V, one of the Linux virtualization tools, what have you. And then on that, you run virtual machines. Almost always the virtual machines that you run have to have an operating system inside the virtual machine that is compatible with the operating system that the servers are running and the virtualization host is running. And that's pretty much true across the board, right? There are variations on that, but generally speaking, if there's Windows, then there has to be Windows all the way up. If there's Linux, there has to be Linux all the way up, and so on. Which is not to say that in virtualization farms and container farms, you can't mix and match Windows and Linux and other operating systems. You just can't do them on the same server, typically. The Kubernetes model is that there is something called the Kubernetes backplane. Kubernetes is abbreviated K8S, and it is the control surface that is used to manage the nodes, which are individual client machines upon which containers run. It's also the surface that you interact with as a developer or a DevOps to get Kubernetes to do things for you. And there are GUIs for that, and the command line for Kubernetes is called kubectl. Typically, the backplane exposes an API that you call, and then it knows how to do all the things that Kubernetes knows how to do, and it does that by interacting with the nodes in order to host your container images. And of course, it knows how to talk to container repositories, which are places where containers are stored. The equivalent architecture in Pivotal Cloud Foundry, or just Cloud Foundry, is that there's a PCF core, which includes an API, and BOSH, which is used to do provisioning. Just like there are Kubernetes nodes, the PCF vocabulary for that is a stem cell. So that's a virtual machine running a very specific set of software designed to host application or service instances that derive from PCF droplets, which are the containers for PCF. That is sort of the overall view of kind of the different strategies. And there are other products with other strategies, but morally they're equivalent to one of these models. The debate comes down to what are the advantages to virtual machines, what are the advantages to containers, and the way that we like to talk about it at Magenic is about use cases. Virtual machines are general purpose computing platforms that you can get low to medium densities on, and containers tend to be oriented towards compute loads, and you can typically get higher densities on them. VMs can be used in stateful scenarios, so you can host a database on a VM and so on. If you're smart, that's going to be on top of some sort of storage tier like a SAN. For a variety of reasons, most container systems, being that they're compute-oriented, are not great places to run things that are stateful. One of the things that VM systems try to guarantee is that the VMs will exist durably and that they'll shut down gracefully. Container systems don't make either of those two process claims. Containers are by their nature ephemeral. Ephemeralness is one of the reasons that you can get higher density. So VMs offer full isolation if implemented correctly, and containers offer pretty good isolation. In other words, typically the container host, or what we call the orchestrator, does a good job of only allowing containers to talk to themselves and other things through a limited series of mechanisms. And again, like everything, implementation is all. You can make virtual machines scale horizontally and vertically. You can make them be HA. In the public cloud, this is often easier because public clouds offer things like availability sets and dynamic scalability. In other words, you can scale things at runtime without having to stop the VM. And container orchestrations, though, provide HA and scalability out of the box. I mean, one of the motivations for containers is that to be able to respond to load and scale, and also have enough instances that they can have high availability. And if you look on my YouTube channel, you'll see there's some nice videos about both of those things that have been done by myself and my colleagues. Virtual machines, to some extent, have a bring your own management system, depending on whose virtualization technology you bought and what subcomponents you bought. You have better or worse management available to you. For container systems, one of the impetus of container systems is to make management sort of built in to the box, and the ability to monitor either VMs or containers varies greatly. As we go in the prescription pathway, in exchange for being more prescriptive, we have to worry less and less about management and monitoring. You know, the trade-off is between flexibility and prescription. We went through and collected a bunch of typical use cases. We've been around for 22 years. We are nothing but an app shop. We build and deliver custom apps for customers. And we look at the use cases. If we take a whole solution that we're delivering for a customer and break it into use cases, this graphic represents, you know, the relative surface areas of those use cases. And so it's extremely rare to hit a use case that can't be supported on the virtual machine, infrastructure as a service, platform as a service sorts of things. And going forward, we're going to sort of make those things morally interchangeable. Container systems like Kubernetes are more prescriptive. Again, they're heavily compute oriented as opposed to state oriented, but in exchange, they make managing and scaling those compute loads much easier. For example, when you move to containers, it's much easier to have blue-green deployments. In other words, deployments that don't stop the application from running in order to do the deployment. You can do those sorts of things on VMs, IaaS, and PaaS too, depending on what your host is. But in Kubernetes and PCF, those things are out of the box. Kubernetes has been around a little longer. There are a ton of pre-made images that you can get and load. Our experience is that the use case surface for Kubernetes is a little bit bigger than for PCF, but PCF offers both developers and DevOps people a ton of really cool advantages. So as you go from the outside to the inside, you're going from less prescription to more prescription. You're going from some cases having to DIY your availability and business continuation to that being built in to the very fabric of these container systems. You get direct enforcement of separation of concerns. You get much easier scalability vertically and horizontally, and you get containers are really designed around this idea of specialization. For example, microservices or n-tier architectures, where instead of deploying big monoliths, we're breaking the system into manageable sized chunks. Teams can maintain their own chunks and ship on their own schedules. And as long as we agree on what our interoperation is going to be, we're pretty happy. As we go further and further down the prescription pathway, we have better support for 12-factor applications. Those 12 non-functional requirements that software architects and technology strategists think of as being table stakes for enterprise application. It's not an either or. You don't have to have only Kubernetes or only PCF or only PaaS or only virtual machines or whatever. We've seen plenty of scenarios where customers through necessity or design have picked sort of best of breed mixes. For example, platform as a service things on public clouds. For example, on Azure, you can get Cosmos or SQL Server, platform as a service, super scalable. All of the platforms offer SQL and NoSQL databases that are highly durable, scalable, available, have support for business continuation scenarios, and the other stateful things too, like enterprise queues and enterprise storage. It's not untypical to mix and match at least two of these. For example, you might containerize in Kubernetes or Pivotal Cloud Foundry your compute loads, but your persistence and storage are all going to be platform as a service. And then, of course, there are systems integrations to existing platforms, to partners, to whatever. There are even scenarios where mixing Pivotal Cloud Foundry and Kubernetes together is super useful, and we're going to do a separate set of videos on the new Pivotal Kubernetes service, which is Kubernetes running inside Pivotal Cloud Foundry, and talk about some of its advantages in another episode. So that's it. My name's Stuart Williams, and I work for Magenic.